Hello friends, welcome to the Edupedia world. In this tutorial, we'll be learning about polymorphism. Polymorphism is a OOPS concept which we have already discussed in our previous tutorial in a gist, but over here we are going to do it in detail and we are also going to do some of the examples. Now let's try. Okay. So polymorphism means many and morph means shape. So poly means many and morph means shape. Okay, so that's why it is called as ability to take many shapes or many forms. Basically, in Java, polymorphism refers to the fact that you can have multiple methods with the same name in the same class. Okay, and there are two kinds of polymorphism in Java. One is overloading and other is overriding. Overloading means two or more methods with different signature, and overriding means replacing a inherited method with another having the same signature. So basically, overloading is something like there are although two different methods, but their signature are same. So you can say the name of the method is same, but the signature is different. So return type is different, number of arguments is different. Fine. But in overriding, everything is like the signature, the name of the method, everything is exactly the same. So we are actually kind of replacing the same method in another class. Okay. So like this is an example in which you can see we are having the overloading. So there's a class test and we do have a main method and then we do have two myPrint methods. First myPrint method just takes the input of integer. So static void myPrint and it is taking the input as int I. And then we are printing that value. In the second void myPrint method, the static void myPrint method is taking the input as double D and it is printing the double value. So you can see it's the same method. I mean, the method name is same but signature is different because we are having different parameters. Fine. So that's the reason it's showing us the example of overloading. So overloading is actually a compile time polymorphism. Compile time polymorphism is where it is decided at compile time like which method to call. And definitely like whenever we try to call any method out of this, we can decide it depending upon the parameter we are passing. So it can be decided at compile time itself. So that's why it's a compile time polymorphism. Fine. So you can see this will be the output in this case. Since int I is equal to 5 and double d is equal to 5.0. So I hope so it's absolutely fine. So let's move forward. Okay. So why overload a method? So why do you think that we need to overload a method? Okay, so let's see that. So you can use the same names for methods to do essentially the same thing. Okay. So for example, println. So you can see println is a Java defined overridden method. So it takes number of different arguments like int, double, boolean, string, etc. So basically what you are doing is the thing you are doing is you want to simply print, but what you want to print can be of a different data type. So now instead of making different methods to print, a string or to print a double or to print something else, why not just create a method with the same name and just overload it by passing different, you can say, arguments. Okay. So whenever like the signature is changing, then it is said to be method overloading. So in case of overloading, the signature must change. So the signatures include number and type of argument and order of argument also. Fine. Return type is not a part of signature. So even if the return type is same or different, it doesn't impact overloading. Fine. And yeah, so you can see example over here. So you can see you can supply default for parameters. So there is a method int increment, and in this you can actually pass int amount or you can pass nothing and just a default while returning something. Okay, so you can basically in this we are calling another increment method from this increment. So whenever a user like just try to increment without passing anything, this increment by count 1 is getting called and finally this increment gets called. Okay. So there's another like you can supply additional information. So this is like void print result and total average. And then we are also having another void print result which is taking a message. So it's like message and then it is calling print result. So sometime maybe you just want to don't print any message, and sometimes there is some defined message that you want to print. So if there is a defined message, you can call the print result with the message. Otherwise, you can simply call this one. So even if you're calling with the message, so this method is again calling this method to print message appended by this string. Okay. So I hope so it's clear. Why do we need overloading? Okay, what is dry? Dry means don't repeat yourself. There's a rule. When you overload a method with another very similar method, only one of the following should do most of the work. So, for example, we have void debug and then we are printing something in it, and then, first and last, and then we are actually printing the dictionary using a loop. And then we have another debug which is taking string s. Okay, so this is like whatever the thing that you are passing is doing that thing. So the rule says that when you overload a method with another, a very similar method, only one of them should do the most of the work. So just make sure whenever you're creating a method. So if you're creating a method, just make sure it's doing some particular work, and it should not be like, like there are two similar method, but both of them are doing similar kind of work. It should not be there. If it is so, then you must create one method only. Okay. Another reason to overload methods, you may want to do the same thing with different kind of data. So let's say there's a class student which is extending a person. And then there is a method void print information. So this method void print information is having two methods, which is print personal information and print grade. Then we have class professor which extends person, and again it is having that void print information and two other methods associated with it. So you may want to do the same thing with different kind of data. So in print information which is associated with student class, I actually want to print the information but of a student, and in the professor I want to do the same thing but with the professor. Okay, so this is like one of the another reason to overload a method. Then we have print and print again methods which are heavily overloaded because they can take different types of arguments. Okay, so this is an example of legal assignment. So this is an example of widening is legal and narrowing is illegal. Fine. So you can see over here I have taken double D and I have taken int I. Then what I'm doing is D is equal to 5 and then I'm doing I is equal to 3.5. So when I'm doing D is equal to 5, it's legal because double can take a integer value. But when we try to, incorporate a floating point with integer, it will give us an error. So it won't be legal, it will be illegal. To make it legal, we need to cast it. So yeah, that's what it's saying. Widening is legal and narrowing is illegal. So I hope you have got the concept. And when we talk about, these concepts, so there is you can say a sequence, like how it is done. So whenever widening is to be done, so there's a preference given. First preference is given to the same data type. So if there is like widening into int is, then that's the first preference. Then it's given to auto widening. So auto widening is like, storing integer in a double. So this is like kind of auto widening thing. Okay. And after auto widening, we have auto boxing. So auto boxing includes about the wrapper classes. So we'll be studying that shortly. And after auto boxing, then we have super class types. Like if there is like a class student and there's a class person, and student extends a person. So person can be casted to student and so on. And last is vararg. So finally, the string varargs that we use, this can also be casted into that. And when we say like auto upcasting, so when we talk about auto widening, every primitive class can be extended to its wrapper class. And firstly, auto widening is done. Auto widening is if there's a byte, it can be, widened into a short, int, long, float, double. So this is the sequence. And once that is done, then byte can be widened, or I can say auto box to the byte wrapper class. So this is how it's done, but a byte cannot be auto box to a short wrapper class. It must be auto box to byte wrapper class only. But don't worry, we'll be also doing examples of this in detail. So let's move forward as of now. Okay. Real method calls. So this is like one of our real method call where we are like having a myprint method, and the input that it is taking is double D. Double can include int also. So when we pass integer 5, then it's acceptable. Fine. It's real because parameter transmission is equivalent to assignment. So myprint 5 is like double D equals to 5 in SOPD, which is fine. What are illegal methods called? So let's see over here. So we are having a parameter to take integer, but we are passing double 5.0. So that is not acceptable because narrowing is not allowed. Then Java uses the most specific method. So let's say we have a class test, and then we have a method public static void main. In the main method, we are calling two of the methods. One is having input 5 and other is 5.0. Now, when we call myprint with the 5, then the method that is having a parameter of int I will be called, and when we are calling it with 5.0, then the double will be called. So it actually try to match the data type. So if it finds the same data type, so that's the first preference. Okay, so it will call that one. Okay, then you can overload constructor as well. Yeah, definitely you can overload constructor. We have already seen that when we were studying constructors. So you can have a constructor without arguments, and you can have a constructor with arguments, and depending upon how you are creating the object, that type of constructor gets called. Okay, so we can have multiple constructor. One constructor can call another constructor in the same class using this keyword. But there are special rules. You can call the other constructor with the keyword this. The call must be the very first thing the constructor does. So it cannot be like after writing some statement you are doing this. Okay, it has to be the first statement. The common reason for overloading constructor is to provide default value for missing parameters. Fine. Okay, now let's study superclass construction. The very first thing any constructor does automatically is called the default constructor for its superclass. So, yeah, there has to be a default constructor for superclass. So, let's say we are having a class foo which extends bar, and then we have a constructor of foo. So, like there's a call to super. Like super will actually call the constructor of bar, and this is an invisible call to superclass constructor. So even if you are not writing super yourself, it will be implicitly present there, and the constructor for bar will be called. Okay, you can replace this with the call to a specific superclass constructor. So if you don't want to, call the default bar constructor and you want to call a parameterized constructor in bar class, then you can do that by calling super and passing the parameter. So as shown over here, there's a class who extends bar, and then we are having a parameterized foo constructor, and we are calling super with name and size. So we are explicitly calling the super class constructor. Okay, then unless you specify otherwise, every constructor calls the default constructor for its superclass. So if you are not specifying, it will call the default constructor. You can use this to call another constructor in the same class. So if you want to, call another constructor in the same class, then you can use this and pass the parameters explicitly. You can use super to call specific superclass constructor. That is something we have already seen. And since the call to another constructor must be first thing you do in the constructor, you can only do one of the above. So you cannot do both this and super, either one. Okay guys, now we'll be studying about the shadowing. So what shadowing is? So let's see this example. Over here we are having a class animal, and then in this class we are having a string animal. Then we have written a main method. In the main method, we are creating an object of the class animal. So that is absolutely fine. We are creating an object of a class animal. Reference is also of animal. Then we are creating a class object of a dog class with reference of dog itself. So You can see dog class actually extends animal, and then there is a string called name dog. So there are data members in both the classes with the same name, that is a name. In dog class, the string name is dog, and in animal class, string name is animal. Now what we are doing is we are printing animal.name and dog.name. So the value that these will print will be animal and dog. Why so? Because when we are calling animal.name by the animal object, so the name that is like animal is having, that will be called, and when we are doing it with our dog.name, the dog will be called, because these are data members, and data members are actually not overridden, only member functions, that is methods, are overridden or overloaded. Okay. So animal class will anyway include its own name, and dog will only include its own name, so they cannot be like overridden. So this is called shadowing. Name in the class dog shadows the name in animal. So basically, because it's having like the same uh, name and the same data type, everything is exactly same. So the shadowing is happening over here, where name in the class dog is shadowing the name in class animal. Fine. So let's move forward. Okay, so in Python, if you have named a variable list, I mean it's about Python, so yeah, so if you have named about a variable list, you could no longer use list method. Okay, this sort of problem is very rare in Java. Java figures out what kind of name refers to and puts it in one of the 6 different namespaces. So, like if you have written some variable, so it's not like you cannot use that method with the same name. You can definitely, because there are 6 different namespaces. One is like the package names, then we have types name, fields name, method name, local variables name, and label. So if there is a list with the label, then you can also use it as a method name. So there is no problem with that. So we have 6 different namespaces. Okay, so this separates issues from overloading, overriding, and shadowing. So this is something that we won't face issues with overloading, overriding, or shadowing. So far we have already seen what's overloading and what's shadowing. Now let's see what is overriding. Fine. So this is an example of overriding. So you can see we are having a class animal. Again, we are having a main method, and then we are creating an object of class animal. Then we are creating an object of class dog as well, and dog is extending animal. Now dog is having a method print, and which is printing subclass dog, and animal is also having a method called print, which is printing superclass animal. Okay. After that, we are calling both animal.print and dog.print. So when we call animal.print, basically superclass animal will get called, and when we print dog.print and subclass dog.print. I hope so. That's like a very simple example, because the object and the reference is of animal, so that's why the animal is getting called, and when we are doing it with a dog, then the dog is getting called. So basically, we have overridden the method print in the subclass. Fine. So this is like overriding of methods, and method print in dog overrides the method print in animal. A subclass variable can shadow a superclass variable, but a subclass method can override. So variables are always shadowed and methods are always overridden. How to override a method? Well, create a method in subclass having the same signature as method in superclass. That is, create the method in subclass having the same name and same number of parameters. Parameter name doesn't matter, just their types matter, and the restriction is like return type must be the same. So when we say return type must be the same, in case of overloading, it doesn't matter like if return type is same or not, but in overriding, it does matter that return type must be the same. Only we can change the number of parameters or the types of parameters. Means the signature part can be changed. Okay. So that was about the overloading restrictions, and another is like overriding method cannot be more private than the method it overrides. So the restriction, as I told you, need to be loosened up. It should have less restrictive access to the overrided method, and we'll see how to do that just now. Okay. And just remember that only inherited methods can be overridden. If there is a method which cannot be inherited, suppose there is a private method, so that private method cannot be inherited. So that method cannot be overridden. Okay. Then excess modifier, as I've written the restriction, it can be either same or less restrictive in case of a overridden method, and final and static and private methods cannot be overridden. Why so? Because static is associated with the class. Final, obviously, it's not meant to override. Final means once written will always be there as it is, cannot be override. And private, definitely it cannot be override because it cannot be inherited. Fine. And I mean, the return type must be same. Um, and the return type can only be changed only if the new return type is a subtype of declared return type. There's a base class is returning something, and when the subclass is returning, the thing that is returning is actually the subtype of something that superclass was returning. So in that case, it's fine, but otherwise return type should remain same. Only number of parameters, the type of parameters can change in overriding. So I mean, it has to be like the same thing. Only like I mean, the signature, everything has to be exactly same. So this is like something a restriction in overriding. So yeah, now let's just see some of more things about why do we need to override a method. So let's see, there's a class dog equals to new dog, and then we're printing dog. So it will print something like dog at the rate feda. So this is like just a, if we print the object, so this is what similar to this is getting printed. And the print again methods called the toString method, which is defined in Java top level object class. So there is an object class which is having a method called toString. Okay, so print again method actually internally calls toString method. Hence every object can be printed, and Java's method public string toString can be overridden. Fine, because like it's there no object class, and every class inherits from object. So yes, toString can be overridden in any classes. So if you add class dog to the following, like public string, toString return name, so it's fine. So then the system out.println will print the dog name instead of printing the object. So it can print something like Fido, like whatever the name that you have given. Okay. So it's almost always a good idea to override toString. Why so? Because whenever you are printing an object, you don't want to print simply the object name. Rather, you want to print something meaningful, like, whatever the values that you have given in that particular object. So it's always beneficial if you override toString method and provide whatever you actually want to print. Fine. So that was what I was trying to say. And then it also helps to debug, because when debugging, it helps to be able to print the object. So you don't have to, every time call getter and setter to print out the objects, rather by just calling toString method, or even you don't have to call the toString method. Just if you try to print the object, the toString method gets called, because print again actually calls the toString method by default. Okay. Now, when you concatenate an object with a string, the object's toString method is automatically called. You can explicitly call an object toString method. This sometimes helps in writing unit tests. However, since toString is used for printing, it's something you want to be able to change easily without breaking your test method. Okay, so yeah, you can do that, and it is usually better to write a separate method similar to toString to use in your JUnit test case. So if you're writing JUnit test case, so you can, just for testing purpose, you can create another method which is similar to toString rather to break it. Okay, so that was about toString. Now let's study about assignment. So when do you consider actually these two things as similar? When I talk about things one equals to new thing, and thing two equals to new thing, do you think are these two equal? Well, actually it's up to programmer. Okay, but consider this. There's a thing three which is equal to new thing, and then we have thing four equals to thing three. So, well, are these equal? Yes. Why? Because they are actually the same thing. So, because when we have created the object thing 3, we are actually creating a reference of thing 4 and we are assigning it to the same object which thing 3 is assigned to. So, this is like always will give you true if you just try to compare thing 3 and thing 4. But when we talk about thing 1 and thing 2, it's up to the programmer. So, how? So basically the equals method. The primitive can always be tested for equality with double equals to. So when you want to compare int a is equal to 1 and int b is equal to 2, if you want to compare these two, you can check if a double equals to b. So it will give you false because 1 is not equals to t and double equals actually will check you like it can easily give you the correct result if it's a primitive type. But for objects, double equals to test whether the two are same object. So instead, like if we are having two string ABC and ABC, they may or may not be equal. Why so? Because they are having a different memory location and they may be allocated to different objects. So if it is different object, then it might give you false even if the value is same, but the object is different. So actually double equals to is used to check the values. So it's actually check the reference equality. So if you want to actually just check the values and the object can be tested with the equals method. So public boolean equals object O, which is in java.lang. It's also a method of a object class. Okay, you can override this method and you can use it to match the like the particular text that you want. So if you don't override it, this method will be just as double equals. If I'm writing a class person and I want to use equals method on two object of person 1 and person 2, if I simply use equals, it will still internally call or use double equals and it will give me false if I've created two objects using new. But if I override equals and I just manually am going to check person one dot name equals to person two dot name, then it might give me true depending upon if I have given the same name for person one and person two. So that's the advantage of overriding equals method. And this method is already overridden for string class. So when you use equals method with string class, it actually compares the values, not the references. Okay. So what's the summary? Well, it says like never to use double equals to test the equality of string or arrays or other objects. Okay, why? Because it is actually going to check for the references for the objects. Rather use equals for string. Java.util.arrays equals a1 comma a2. So like over here the arrays are getting compared using equals method. Okay, so if you test your own object for equality, then you need to override equals method. Fine. Now calling an overridden method. When your class overrides an inherited method, it basically hides the inherited method within this class. Okay, but not from the different class. You can still call the overridden methods by prefixing the call with super. So you can see there's an example where we are doing super and then we are doing print everything. Yeah, over here, so you can see like within your class you can still call from your main method you are calling that method and within that method you can call the method of a super class by using super dot and then the method name. Fine. You would mostly like to do this in order to observe the dry principle that you are not, rewriting the same code again and again. If like you want to execute 5 lines and 3 lines are already written in some of the method, so why not just execute the 2 lines from that method and call the other method which is already having 3 lines. Okay, then to rewrite the code. So that's the purpose. The superclass method will do most of the work, but you add it to it or adjust its result. This isn't a call to constructor and can occur anywhere in your class. Okay. So since it is not called to constructor, so it does not have to be the first call. You can even call it after by writing 10 lines of code. So well, This was about calling an overridden method. And okay, now we have came across overloading and overriding. Now let's just go through the summary. You should overload a method when you want to do easily the same thing but with different parameters. So if the parameters is different but the functionality is whole and or same, then use overloading. You should override the inherited method if you want to do something slightly different than in superclass. So if you're doing something in superclass and you want to do slightly something different in subclass, then just override the method if there is no change with the parameters or the signature. Okay, then override it. It's almost always good idea to override public static toString because it's handy for debugging. To test your own object for equality, you need to override the equals method, and the syntax is like public void equals, and then in the parameter you do pass object O. Okay, so there are special methods in java.util.arrays that you can use for testing, like the equals method of arrays. Okay, and lastly, you should never intentionally shadow a variable because that might create confusion in your program. So you should not shadow a variable. Okay guys, so I would like to end by saying like Java is focused on being a powerful but simple language which is easy to read with a consistent clear meaning. It is more important than Java programs to be easy to read than to write. So it's like really important to able to read the Java program very easily because usually Java program do have some big applications and those big applications is maintained by huge number of programmers, and each and every programmer should be able to understand your code very simply or very easily. Okay, so that's the intent. Okay guys, so thank you very much. Now let's meet in the next video and try to do some handy examples. Thank you.